So my name is Kristin. I'm a PhD student here, and thank you for having me speak with all these professors and really great talks here. It has been very, very interesting. And I'm going to talk about outliers today. And before I became a PhD fellow here at DIKU, I was actually a machine learning engineer at Ørsted. And I model temperature and vibration data. And I spent a lot of my time cleaning data as well. And that's actually the first time that I got a little bit curious about the concept of outliers. Because when you spend a lot of time cleaning data and do data analysis, you're always faced with this uncertainty about outliers in your data set. Like, is this noise? Is this a measurement error? Did somebody mess up the data entry here? Or is this an actual important data point that needs to be taken into account in my analysis? And when I became, when I became a PhD student here, I got access to this data set of Asylum case summaries. And I realized, wow, okay, now my data points are actual people. So especially in this high stakes domain of Asylum, every data point counts. So I really need to take a look at this. So the topic today is AI, machine learning, and machine learning really is a technology of majorities. It works really well if groups of people are very well represented in your data, and it also famously does not work very well if you don't have, if your representation in the data is not very well. So today I would like to attend to these minorities, to these edge cases, and to these outliers. And especially in this area of asylum decision making, so I'm talking here about using machine learning in public decision making. So the question, the overall question of the project that I'm working in is, can we use AI to take decisions, for example, in asylum? Can we predict decision using like a certain data set? And yeah, so outliers. Outliers have a really bad reputation. I ran actually a search on the online publishing platform Medium, so that's where data scientists and other people share their wisdom on different topics and write articles. So I searched on the topic of outliers and a lot came up. These are just two examples. The first one, use outlier detection and removal to improve a data set. So a good data set, an improved data set, is one without outliers. That's what I'm reading from this one. And my favorite of the many, many that came up are outliers, the silent killers. And this is an article about killing your model accuracy, basically. And I would like to talk a little bit more about if you actually study outliers. So if you put them in the focus instead of just dropping them from your data set, how you can learn a little bit more about the phenomenon you're studying. So first I would like to share a little bit like general thoughts about the concept of outliers, and then I dive a little bit deeper into our case studies and show you some diagrams, which I'm pretty sure you're super interested to see. So, what's an outlier? What's the definition? It's a data point which is significantly different from other data points, or it does not conform to the expected or normal behavior. For me, the immediate question here was, what is this normal behavior? What does that mean? I need to look at this in my data set. And let me start by really giving you an example here. So if we look at asylum seeker citizenship as the only data feature, then, for example, stateless people are outliers. So the norm here are people with an ID or a passport, but there are also people who don't have an ID or a passport. So the identification process here is a little bit different. But that's only one example and one view of what could be an outlier. So who counts as an outlier really depends on several aspects. It first and foremost depends on who is asking and how are people actually represented in the data. Mikkel alluded a little bit to that, but data can always only represent a fraction of a subset of a person, right? So each one of us can be represented in a data set by age, gender, citizenship. So what's being measured in our person really counts here. And then it also really depends on how the norm is constructed. But in the case of asylum seekers, what is a normal asylum seeker, or what is a range of a normal asylum seeker? If you ask a caseworker, they'll tell you, man, every single case is different. There is no norm, there is no normal. We really have to go on a case-by-case basis. But how do algorithms then calculate a norm and can tell you who an outlier is and who isn't? So let me drive this point home and tell you a little bit more about our data set. So we have access to a data set of 17,000 Danish case summaries of the last 20 years. So each data point is a text file, and it contains personal information about the asylum seeker, interview data, and their asylum motive and the decision reasoning. And for the examples I'm going to give you, we chose to represent each person, or each text file, each case actually, as word frequency lists, which gives you a really, really, really long vector. We did some dimensionality reduction, so this is what, so to visualize it for you to see. And then we applied 3 different kinds of outlier detection algorithms. And there are many, many different kinds of outlier detection algorithms. It depends very much on the type of data that you have and what you basically are looking for, what you want to find out. We used the 3 to kind of visualize or kind of show what are the different ways of constructing the norm. So I'm going to just briefly tap into this. So the first one is called local outlier factor. And that's a density-based algorithm. And for each data point, the density of this data point is compared to its closest neighbors. So in our case, we chose 20 neighbors. So you can see the red point here, for example. That is an outlier. So this outlier is compared to the yellow points, which are its closest 20 neighbors. So the norm here is constructed with its closest 20 points, or its 20 most similar points, basically. Another point, or another algorithm, is the Gaussian mixture model. It's a clustering-based model, so it clusters data points together in groups. So if a data point doesn't belong to any of the clusters, and you calculate that based on the distance, it's considered an outlier. So here the norms are several groups or clusters of data points. We also did a third one. It's an angle-based outlier detection algorithm. I will skip that one because I really would like to talk about the outliers. So who are the outliers? Who did we find? Who did our algorithms find? All in all, we found 27 outliers. 8 of them overlap, so all 3 algorithms detected these 8 points as an outlier. And I would like to talk a little bit about these cases, because I started out with just reading them, and some of them were 70 pages long, so that was quite a feat. And I looked for both things that made them stand out, and also commonalities and patterns. So, who are some examples? So there's one case of a deaf, analphabetic asylum seeker, and she traveled with her cousin, who was explaining her asylum motive in interviews. And the cousin could explain that there was some kind of threat of a local terror group, but she couldn't really give a lot of details. She was also not able to communicate with her cousin. And that made it very hard for the caseworker to actually evaluate credibility, because that's the essence of an asylum application. It's evaluating their credibility. And that led to the asylum seekers being denied, and to numerous appeals by their lawyer. Then we also have 2 outliers about people who actually did receive asylum in Denmark, but then they committed a crime. And by Danish law, their residency was immediately revoked. But the Danish state still accepts their asylum motive, so they accept that if we send you back to your home country, your life is in danger. So we cannot really force to leave you. So that leaves them in a kind of limbo. So that was definitely a point for us to dig into. So what happens there? What happens to these 2 people? Another one, which I've also found very interesting, is a mother with a kid who also received asylum in first instance, but then a couple of years later, her credibility was questioned and her asylum was revoked, but her 4-year-old child's asylum was still there. So also an opportunity for us to dig a little bit deeper. What happens in these cases? We also detected some patterns there. So all the cases, all the outlier cases have been processed at the immigration services in Denmark before. So for some reason, the cases were appealed or taken up again. So another thing for us to look into, like, okay, what are the reasons for taking up these cases again? We also have, all of them are about minors, and 7 out of the 8 cases have maturity assessments involved. And so these minors were assessed on whether they're mature enough to go through an asylum case. That was definitely something very interesting. We dug further into it, and if you want to learn more about it, chat me up during dinner. I'm happy to tell you more about it. Yes, but I also want to tell you about, we also asked a caseworker about who are the outliers for you. So what's a caseworker perspective? Who is an outlier for you, and how does the Danish asylum system account for it? And he said, and I quote, "So the outliers could be a decision that just appear unreasonable. We try to make sure, and that's the important thing here, that we coordinate, we do things thoroughly and properly. And if you have a case where we see it hasn't happened, there we will try and repair and fix it. Yeah, we don't like outliers, we try to eliminate those." So it's very interesting. For him, an outlier was a reason to fix something. It was an instigator of change, so a change in their procedure or in their practice. It's actually interesting because I'd also talked to a colleague in the law department, and he also said, like, outliers for us, that's precedence cases. So this is actually a change in precedence in the law. So that's the specifically very important cases here. So, interesting perspective from there. Why should you care about this? So I have some takeaways here. First of all, outliers can tell you about the phenomenon that you model. Very often when we are PhD students or also in the industry, you get a data set, you get data, and then you go right into the interesting part and do a prediction model, machine learning model, and we want to go with the latest, really the latest technology and the latest algorithm. I'm guilty, I'm doing that as well. But sometimes it really makes sense to take a step back and really ask, what is it that I want to achieve? Is it really the goal to apply the latest machine learning algorithm, or do I want to learn more about something? And maybe asking people or looking at outliers is more beneficial to that than just going straight for the interesting technology. By the way, not only individuals do that, companies do that too. I have been part of that as well. Then, algorithms encode norms and values and not only data. So there's been plenty of research into how biased data results in biased output. So garbage in, garbage out. We've all heard about this, and that's definitely true. But we need to face it, algorithms also contain assumptions, values, and norms. And data analysts design algorithms and take decisions to optimize model accuracy. And we really need to pay attention to what downstream effects do these little decisions that data analysts do have on real-life subjects. And that leads me to my very last point. We need to map our algorithms back onto reality and understand their impact. So again, little decisions that the data analyst makes has an effect in reality, and just mapping that and trying to understand what is it that I'm actually calculating here? What is my algorithm doing? What are the points that we're dropping? Really can have a big impact in the real life. And that's all I wanted to say. Thank you.